Hi everyone, welcome to Campus X. In this video, we are going to see how you can create and run multiple processes in Python. What is a process? A process is just a program in execution. It's just some code that is running parallelly in a computer. But why is it called a process? Why not a program if they mean the same thing? Well, in the earliest computers, only one program used to run. But as the need of running multiple processes rose higher and higher, handling multiple processes became more important. Here is a screenshot of my task manager where you can see that the Chrome browser has so many processes running when I took the screenshot. But even on a CPU with just one processing unit, how can you run multiple processes? The CPU actually switches between processes and runs only one process at a time with a guarantee that it gives enough time to all the running processes. Here is a small graphic which depicts how a 2-core CPU might handle multiple processes. So here you can see only a maximum of 2 processes are running at a particular point of time. Now that we have seen what processes are, let's parallelize our code in Python. So here I have my old setup. So here I have imported sleep and time. I am noting down the start time. I have a function which does something. It actually sleeps for 1 second. Before going to sleep, it prints out it's going to sleep. It takes an ID parameter to identify what instance of the function is running. After waking up from sleep, it prints woken up, and at the end we note down the start time, and at the end we print out the time that this main process took. So now let's say we have to run this something method in a separate process. So first of all, we need to import multiprocessing. Import multiprocessing. Next, we need to create a process. To create a process, we write multiprocessing.process. Inside it, we pass in a target. The target is the reference of the function that we are willing to run in that process. So here pass in something and do not put parentheses here. When you have ID, when you have arguments to pass to this function, you can pass it in the args parameter as a tuple. Remember, here it does not support list as it did in threading. You have to pass a tuple. So here let's say I want it to be an ID of 0, and you have to pass in a comma to mention that this is a tuple with one element. Now that we have created this process, we need to start it. p1.start. So what it should do is, first of all, note the start time, create the process, run this function. So it should print going to sleep, and then after sleeping woken up, and at last the main process should end. So let's run this. Okay, so first of all, what is happening here? In Windows, this problem comes up. So what you have to do is, whatever thing that you want to run in this main script, you have to run under this if name equal to main in this, and I'll just put it inside that if. I'll note the start time in my main module. Actually, the earlier thing I have seen that it works in Macintosh, but here in Windows you have to put this name equal to main. Now if you run this, you see, okay, the main process ended in 0 seconds, then it says going to sleep, and then it says woken up. So what actually happened here is the main process, it started the background process, but our script continued. Now processes take a little time to get created and started. So before our something function could print going to sleep, our main process had already gone, and it printed main process ended. So I would like a feature where the main process waits till its children processes have finished execution. So for that you have function called join. So what happens is the main process will wait here until P1 has finished its execution. So now if I print, now if I run, I actually got to do that there. Now it's saying going to sleep, woken up, and the main process ended in 1 second. Okay, so whenever you are in Windows, just remember to put this name equal to main. Now this was just one something function that we ran in one process. What if we had to run 10 something functions and we want to run it in different processes? So let's just create a processes list, just as we did in multi-threading. Multiprocessing.process, I'm using list comprehension to make 10 different processes. So something with args equal to a tuple of, let's say, I, where I'll write for I in range of 10. I want to make 10 processes. Okay, I am just deleting all of these. Now what we want to do is for process in processes, we do process.start. Okay, start. Now you might be tempted to do process.join here, because we want the main process to wait until all the processes have finished execution. But running join here, it would mean sequential execution, because the main process will start a process, wait for that process to join, then another process will be started, it will wait, and this will mean sequential execution. That is not exactly what we want. So in this case, we have to make another for loop. So here first we are starting all the processes, and then we are waiting for all the processes to complete, and we are noting the end time. Let's run this. Okay, all our processes got kicked off, but they were not in the order that we specified. They did not also wake up in the order that we specified, because processes take a little time to get created and the order is not necessarily maintained, because the scheduling algorithm does not take care of the fact how we start the processes. One cool thing that you can do here is you can get the process ID of this something function to see in what process we are running. But before actually doing that, let me just bring up my task manager to show you all the processes that are running. So first of all, I have my OBS Studio, don't worry about that. I have my PyCharm, which only has 2 processes running. Now if I run this script and go to my task manager, you will see so many Python processes that came up and it went away. So I am going to increase the sleep time just for your sake, to notice that all the processes are displayed in the task manager here. So all these Python processes are what we created, and after 5 seconds they'll go away. And you can also see this in the details page. Let me go where P is. So here you can see only PyCharm is running. Once I run this, you will see all the Python processes get kicked off, and after 5 seconds they will die off. And you will also see the process IDs here. What you can do, you can print them here and check whether they are same or not. So I'm going to write PID is, for this thing you have to import OS, and we are going to write os.getPID. os.getPID. Now if I run this and bring up my task manager along with this, you can match these process IDs with these running processes. Okay, now that we know how we can manually create these processes, let's see some process synchronization issues. Okay, I have this previous setup where I was developing this accounting software in my thread synchronization video, which is the first video of this tutorial series. Here I have a balance. It has 200 whatever currency you want to interpret it as. It has a deposit function which takes in an amount and times, and our special requirement for this deposit function is that the balance will get updated or get added by the amount, the number of times that this times variable has. The withdraw function reduces the balance by the amount for this time. Now we want to run these deposit and withdraw functions in different processes, not threads. So for this, what we do, create a deposit process by calling multiprocessing.process process, I already have multiprocessing imported, and in the target function we pass in deposit. Do not run this function here, just pass in the arguments. So for the arguments here, first of all I want to increment it by 1, suppose $1, and I want to increment it 1000 times. And in the withdraw process, let's say withdraw process, I want to decrement it. Let me just type it out first. What am I typing? Process target. Target is our withdraw function, and in the args parameter I'm going to decrement the balance by 100 times, not 1000 times, to demonstrate to you a fact. So deposit process dot start, and so here I have the deposit and withdraw processes started, and here I am waiting for that to join. Now at last I'm going to print what my final balance is going to be. Balance. So first of all, it should increment, actually in a different process, in the deposit process it should increment the balance 200 by 1000 times, and in the withdraw process it should decrement it by 100 times. So let's run this and see. Okay, so the runtime error again popped up. So what we have to do is put everything inside this if name equal to main. So in Windows you want to remember this, otherwise it recursively forms multiple subprocesses. Yeah, the balance is still 200. Why is it so? Though this balance is getting updated in different process, why is it 200 still? So the key idea lies in the process creation concept. Let me just demonstrate to you that. So every process has a separate memory space. When you create a second process from a first process, the parent process's memory space gets copied to the child process's memory space. So here you can see a result variable which is an empty list, and inside this when you create this process P2, this result variable gets copied. Now whatever changes that you want to have in your result, it stays in that process's memory space, and the actual memory space doesn't get actual variable in our process one that we want to get updated does not get updated, because it is a completely new memory space. So what can we do about this? So when we create this deposit process, what happens, the balance amount gets copied to that deposit process, and whatever changes are made on the deposit process's balance variable. So these two processes are updating their own balances and not the main process's balances. What we want is, we want to update the balance in our main process from these deposit processes. So the fundamental difference between threads and processes are that threads share the code data files section of their parent process, but processes do not share their memory. So there are normally two methods of sharing memory. First of all, inter-process communication. First is shared memory, and the second is message passing. How shared memory works is that you create a shared memory space, and process A writes to that memory, process B reads, process B can also write here, and process A can read from here. So you are using this shared memory for the communication between these two processes. Another way is message passing, where one process sends a message to the kernel, and the kernel does the job of sending that message to the required process, and this it continues. Now in this video we are going to implement this shared memory, and let's see how it is done in Python. So this multiprocessing module gives us some classes that we can use. So first of all, we don't want this global variable, it's anyway not working. Next, we want this balance variable to be multiprocessing dot value. This value is the shared variable. Now we want to initialize this value by 200. First of all, we need to pass a type. In the type parameter, you can pass in a 1 character code or a C type. So this I means integer, and If you write D means float. Here I have listed all the one character types that are available for that value to process. So here I means integer in Python, whereas it's signed integer in C type. Capital I means, it also means integer, and in Python actually they provide only minimum primary data types. So Python almost everything is int except all the float and double that C gives are represented by float in Python, because this has a higher level, right? Python is so much powerful. And you can also pass some C types. For example, one of the C types is cint, and we need to import it. When I press Alt Enter, from C types it imports cint. Okay, like this you can import C double, but you have to import it, of course. Here I have listed all the C types that can be used along with that value variable. Here you can see the corresponding Python types and you can use them. You can take a screenshot or you can look up the documentation. Okay, these are the types that you can pass: one character type code and some C types. Okay, so for this I'm going to stick with the integer value I, one character code, and I'm going to remove that import and I'm going to initialize it by 200. Okay, next thing I'm going to do is pass this balance variable, because this is a shared memory. So we have to tell the processes somehow that we are passing in a shared memory, shared value. We remove these global variables. Okay, and we add the balance here. Now let's see. Okay, so it gives us some synchronization issues because you cannot write balance plus equal to. It has a specific parameter called it has a specific property called value. So this is a value class, right? So it has a specific parameter called class variable called value, in which it stores the actual 200. So you have to write balance.value plus equal to amount, balance.value minus equal to amount, and at the last when we print out, we pass in the balance.value. Now let's run. So it prints out 1106, but that is not what we want, right? We have this 200, we are incrementing this 200 by 1000 times, so it should be 1200, and then we're decrementing the 200 by 100 times, so it should be 1100, not 1106. So it turns out it has the same problem. It has these synchronization issues. Whenever both of these updates come at the same time, only one gets processed, the other gets lost. So what we need is something called a lock, right? So let's create a log variable, multiprocessing.lock, lock, and we pass these locks as arguments, and of course we have to receive them. Lock, first of all we have to acquire the locks and then after that we need to release the locks. Now it should print out our desired result, and there we go. It says 1100, and no matter how many times I do this, let's do this 10,000 times and 1000 times, it should print out 11,000. So let's run. Whoops, I calculated it wrong, not 11,000. So it's actually going to be 9,200, and no matter how big these numbers are, it's going to be same, because it's synchronized using locks. Okay, now creating processes in this fashion has become older, because process creation time is a major overhead. You don't get a bounds on the number of processes that can be running at a particular point of time. So this has many disadvantages, right? So what we're going to learn next is something called a process pool executor. So here I have the setup ready. Here are the something function, and instead of printing the woken up, I am just returning it. Here I am noting down the start time and mentioning that the main process is starting, noting down the end time and printing out whatever the the time this main process will take. So to use process pool executors, you need to import, okay, from concurrent futures, concurrent.futures, you need to import process pool executor, because it's not in multiprocessing module. You need to import it from concurrent futures. So now what we want to do is make a context manager. Inside this we need process pool executor as executor. Now you can use the submit method to submit this method that we want to run in a different process, so that it runs in a background process. So we can write task equal to executor dot submit. Now here we want to pass the reference to the function that we want to run in a different process. So something, do not run this process here, and since it requires an argument ID, you can pass it in here as this, as just a parameter. If it had some other parameter like sum, you can pass it in here only, like sum. Okay, since we are not using that, I'm going to delete that. So when you submit this function, it returns you a future object. Now on that future object you can apply result to see whatever is returned from this function. Okay, so let me just print out the result that will be submitted. So one more time, the main process starts, it submits this method in a different process, it returns you a future object. When the result is ready, the result gets printed out. Okay, and you don't need to do anything like start or join, because this context manager, the process pool executor, since it's implemented as a context manager, it takes care of everything. Let me just right click and run. Yeah, so it says main process starting, going to sleep, woken up, and voila. Now what if you want to have 10 processes? Well, let's make a tasks list and use list comprehension to submit those processes. Let's say submit something, and the ID is going to be I, and for I in range 10. Now we can print out for result in results, actually for task in tasks, and we can just print out task.result. Now what this will do is this will create 10 different processes and start them. Actually not create, everything is there process in the process pool executor. All the workers are in the running state, and it will run these functions in a particular worker. If you have seen my thread pool executor video, just it is the same as process pool executor. So once we have submitted these functions in a different process, we just print out the result. That's it. Now the advantage here is that the process pool executor will not make 10 processes. Instead, it has some workers ready already in its pool, so it's going to pick up those workers and run this something function. Now the maximum number of workers depend on the number of cores that you have. In this computer I have 4 cores, so I can only 4 processes will be running at a particular point of time. So if you run this, see, only 4 processes got kicked off at the same time, and whenever one process it has finished the execution, it starts with a new something function, and there we go. Now you get a bound on the number of processes that can be running at a particular point of time. Now you have a function called AsCompleted. What it does, let me just import it from concurrent futures. I am importing AsCompleted, and you pass in the future object here, future list here. Okay, now what will happen is these tasks will not get displayed in the order they were started. Instead, they are going to be displayed in the order they are completed. For example, here we had started in order, and they woke up in order, but they will be waking up in this as completed method as they have completed. So let's just run. So not much difference here. So they are going to sleep and they wake up in the order that we started, but we can just reverse this thing and see as completed really prints out the tasks, the result of the task as they are completed. So let us make a sleep time variable here. Sleep time, and let's just pass the sleep time 10 minus I. Okay, so it will be in the reverse order. So the first process will sleep for 10 seconds, the next one will for 9 seconds, and so on. So now if we run, so remember this process is running for 10 seconds, this one for 9. There we go. Now it gets printed in the order they have completed. So this process runs for 10 minus 3, 7 seconds. So it woke up first. This one ran for 8 seconds. So it woke up next. And they are printed in the order that they are completed. So that was the as completed method. Now if you have for example IDs like this 0, 5, 6, 7, 9, you can use the map method. You can use the executor's map method to start these processes. Instead of making a processes list and then printing out the result, what you can do, let's just have a results variable. In it we will pass, we will write executor.map, pass in the something function because that's the thing we want to run, and we pass in the IDs list. So this map function, if you're familiar with the Python's map function, what it does is it runs every something function in a different process with a particular element of IDs list. And what it returns is a list of results similar to this list corresponding to the results of this something process with every element. So now that when you print result in results, you print out the result, so it directly gives you back the result. Okay, let's just remove the sleep time for now. I'm going to have sleep time 1 for all of them. Now that when we run, 0, 5, 6, 7 got started because they were in the order, and then they woke up in the order now they are printed in the order the results are returned. Not actually, they are printed in the order that they were started. Okay, and they still finished in 2 seconds. Ideally in sequential execution it should have taken 6 seconds, but it does speed up your processes. So now you might be wondering that, well, processes and threads, they both do the same thing, run things concurrently, but what is the advantage of one from the other? When do we use one from the other? So that is what we are going to see in the next video.